this video, we're going to be looking at how to integrate basic polynomial equations. And if we have an integral that looks like this, ax plus b to the power of n, it's a very simple integral. The first thing we need is the derivative of this inside bracket here. In other words, we need the derivative of ax plus b. And the derivative of ax plus b, we know in this case, is simply just a. So what I need in order to integrate this is an a next to the ax plus b. However, I'm not allowed to just willy-nilly, just because I feel like it, add an a here. So what I actually have to do is I have to multiply the outside by 1 over a. That way this and this cancel and we're back to where we just started. But in order to integrate this, it's pretty straightforward. The integral will simply become ax plus b to the power of n plus 1 divided by n plus 1, and always, you must include your constant of integration, the plus c. And this is how you integrate any polynomial that is raised to the power of n. And let's have a look at a few examples. The first example we're going to look at here is the integral of 3x plus 2 to the power of 3. So first step, what do we need to do? Well, we need to know what is the derivative of the inside bracket here. The derivative of the inside bracket, in this case, would simply be 3. So on the outside of this bracket, I need to introduce a 3. But again, in math, you can't just add constants just because you feel like it. So I must also times the outside of the integral by 1 divided by 3. And so now the integral of this will simply work out to be 3x plus 2 to the power of 4 divided by 4. And always, plus c. Notice how the 3 and the 1 on 3 didn't appear in my final integral here. That's because I've done one thing incorrect here. The 3 that we introduced here, that had to be here in order to integrate and solve this here. But our final integral was times by a third. So don't forget, you must also times this entire integral by 1 over 3. So our final answer will simply become 3x plus 2 to the power of 4 divided by 12 plus c. Next example, we're going to have a look at how do we integrate something like this. To integrate something like this, we do the exact same steps. What is the derivative of the inside bracket? Well, that would simply be minus 5. So I'm just going to have a minus 5 on the outside here as my scalar multiple. But I can't just introduce constants because I feel like it, so I must do 1 divided by negative 5 on the outside. And now to integrate this, the integral simply becomes 1 minus 5x to the power of 5 divided by 5 plus c, but remembering, we also introduced this other constant on the outside. So I must times by 1 over negative 5. So our final answer becomes negative 1 take 5x to the power of 5 divided by 25. And always plus c. The next example, we're going to have a look at an example like this. The integral of 12x 1 plus x squared to the power of 2 dx. So now we have a bracket to the power of something. We need to recognize what is the derivative of the inside bracket. Well, I know the derivative of 1 plus x squared is simply 2x. And if I have 2x, I need to have that next to it. Currently, I have 12x next to this bracket instead of a 2x. So the solution that I can think of is as follows. Rather than having to integrate this whole thing again and have to rewrite an entirely separate equation, I'm just going to rewrite this as 6 times 2x times 1 plus x squared whole squared. Now what you can recognize is the derivative of the inside bracket here is directly next to it, right? 2x is directly next to this entire bracket here. Of course, we have this extra 6 here, but that's no big problem to deal with. We can simply just move it to the outside, because we know a property of integrals is that scalar multiples can simply be brought out of the integral. So this is what we will have. And now if we want to fully finish off this integral, all we have to do is forget about this term here. Just look at this, add 1 to the power, divide by the new power. So in this case, it will become 1 plus x squared to the power of 3 divided by 3 plus 6. Plus c, sorry. Now we have to recognize this term here, it goes away because it was included in our integral. But the 6 here, we also have to multiply our entire final answer by. So our final answer is multiplied by 6. So that would be 6 on top times 1 plus x squared whole cube divided by 3. And we can see that the 6 and the 3 simply cancel out. So we'll be left with 2 times 1 plus x squared to the power of 3 plus c. And that is your answer for this integral here. Let's keep going. We have plenty more examples. Our next example is the integral of 5 divided by x plus 1 to the power of 2. Now this doesn't look like the standard form that we've just gone through for the past few questions, but we can rewrite this integral using negative exponents. And we can rewrite it as 5 times x plus 1 to the power of negative 2 dx. Now again, we can use the same rule. We need the derivative of this inside bracket to be on the outside. And the derivative of this inside bracket, x plus 1, is simply just 1. It's just equal to 1. So we need a 1 next to it. We pretty much have that already. We can just move the 5 to the outside because it is a scalar multiple, and you'll be left with 1 on the inside. So then what we can do is simply add 1 to the power, divide by the new power. So this becomes x plus 1 to the power of negative 1 divided by negative 1 plus c. But don't forget, we have to times by the 5. So simplifying this out so it's back to positive exponents, we will have 5, or in this case negative 5, divided by x plus 1 plus the constant of integration c. Let's keep it going. Next question, the integral of 10 times 6x take 1 times by 3x squared take x plus 1 to the power of 4. What is the derivative of our inside function which is raised to the power? So in this case, what is the derivative of 3x squared take x plus 1? Well, in this case, it's equal to 6x take 1. Do we have the derivative of this inside function next to it? Well, clearly yes, we have 6x take 1 right next to it here. Of course, we have this 10, which is kind of annoying, but we can easily just bring that out of the integral because it is a scalar multiple. So we can say this is the same thing as the integral of 10 times the integral of 6x take 1 times by 3x squared take x plus 1 to the power of 4. And what you can recognize is this term here has its derivative right next to it. So in the process of integrating, it goes away. So we can just do plus 1 divided by the new power. And that is our integral. So the integral will become 3x squared take x plus 1 to the power of 5 divided by 5. But not forgetting, we have to times by 10. So if we times the top by 10, we can recognize that the 10 and the 5 cancel out to give us a 2. So our final integral, plus c as well, will be 2 times 3x squared take x plus 1 to the power of 5 plus c. And that is the integral of this problem here. Next problem we have the integral of 12 times the cube root of 3x take 2. Now anytime you have surds or cube roots or any sort of a radical function like this, first thing we can immediately do is just write it as an exponent rather than a surd. So we can write it as the integral of 12 times 3x take 2 to the power of a third dx. And continuing on, we know that the derivative of the inside function must be next to it. In this case, the derivative of 3x take 2 is equal to 3. So we need a 3 next to it right here. And what I can recognize is I can split up this 12 as 4 times 3, 3x take 2 to the power of a third. And the reason I've done this is because the 3 is right next to it. And of course, the 4 is a bit annoying, but once again, scalar multiple, you can just bring it straight outside. So what does this become? It becomes 4 times the integral of it. I'll just do it in this line. It becomes 4 times the integral of this function here. And again, This term here simply goes away. All we do is add 1 to the power, divide by the new power. So this becomes 3x take 2 to the power of 4 over 3, because we're adding 1 to this power. That's the same as adding 3 over 3, divided by 4 over 3. And another way of saying dividing by 4 over 3 is the same as timesing by 3 over 4. So I'm just going to say 3 on the top and 4 on the bottom, plus c. But do not forget, we have to times our entire integral by 4. So if I times everything here by 4, we can see the 4 and the 4 here cancel. So our final answer for the integral is simply 3 times the integral of 3 times in brackets 3x take 2 to the power of 4 on 3 plus c. That's how you integrate that question there. The next problem we have is we are going to be integrating 1 plus x 1 take 5x to the power of 2 dx. So in this problem, we have 2 terms instead of 1, so we have to integrate both of these separately. But what I can recognize is we need the derivative of the inside function to be next to it. The derivative of this inside function is negative 5. Is that next to it? Not at all. So hold on a minute, how are you supposed to integrate this using our technique? The short answer is you don't. Okay, all you have to do in this case is manually expand, and it wouldn't take too long to do this, so we might as well attempt it. To integrate this question, it's the same as the integral of 1 dx plus the integral of, in brackets, we can times everything here. So we have x times 1 take 5x whole squared. And to expand 1 take 5x whole squared, it's the same as 1 take 5x, 1 take 5x. This is the same thing as 1 take 10x plus 25x squared. That is the integral there. And then what I can recognize is we have to times all of this by x. And if I want to times all of this by x, all it becomes is x take 10x squared plus 25x cubed. So this is what we can use now. We can start integrating this term here. We know the integral of 1 is simply x plus the integral of this dx. So it becomes x plus the integral of x is x squared divided by 2 minus away 10x cubed divided by 3 plus 25x to the 4 divided by 4 plus c. That is our integral. And we can do one last question for the day. And our last question will be this question here. The integral of 10x plus 15 divided by the square root of x squared plus 3x take 1 dx. What did I say when we have radicals or surds in our questions? Always try to write it as an exponent. Always try to write it in its most simple form. So you can have the integral of, in brackets, 10x plus 15 times by x squared plus 3x take 1 to the power of negative a half. Now what can I do? We need to work out what is the derivative of this inside bracket here. The derivative of x squared plus 3x take 1 is simply equal to 2x plus 3. And do I have that equation next to my function? Not quite, but I can recognize something. If I factorize out a 5 from this bracket, if I factorize out a 5, I'll be left with 2x plus 3. Ah, that's literally what I want in my equation. So in the process of trying to work out what the derivative is, I've just factorized and discovered that my derivative is right there. So now we can do x squared plus 3x take 1 to the power of negative a half. And what can I do now? We realize that we have the derivative of this inside function next to it. The derivative already is there. The 5 is a bit annoying, but again, bring it out. It is a scalar multiple. And now in the process of integrating, this just goes away. All we do is just add 1 and divide by the new power. So what do I get? We can bring this 5 to the outside, worry about it later. If I integrate this, we get, this is the same thing as x squared plus 3x, take 1, to the power of negative a half plus 1, which is the same as positive a half, divided by a half. And another way of saying divide by a half is the same as multiply by 2. So I'm just going to times this whole equation by 2. Plus c. Okay, but we have to recognize that we have forgotten the times by 5, so we must times the whole equation by 5. And 2 times 5 is simply just 10. And that is how you integrate this question here.